Biasma, do you hear
Good
me?
morning po.
Morning po.
Okay. Okay, last week we have already accomplished the midterm, and I have checked your papers. Again, I detected most members of the class are not listening during the lecture. Okay. Only few were able to follow instructions regarding managing of forces and vectors. Okay. Others are should no interest in correcting the errors. Okay. They insist on following the old system. Okay. What they learned in the previous physics class. Okay. Because I'm trying my best to correct those errors, especially managing vectors. Okay. Again, I would like to inform the class that we will not be going out of the vector topic because we will be using this quantity until the end of the course. Okay. Uh, Sometimes I can say the lecture that I'm giving to the class is useless. Okay. Still don't the others, most members of the class are not believing on the lecture. Okay. They believe on the previous lectures that they learned in the previous physics class. I always give example. Okay. Since our midterm is uh, force and motion and what is the scope? Statics. They are almost the same. So let us see. I will check first those who missed the midterm. Okay. Only there are two members of the class who missed the midterm exam. Ann Benisbiete, nandito ba si Ann Benisbiete? And Paula de la Cruz. Are you online now, Ann Benis and Paula Daphne?
Hi, sir. Yes po. Good morning po, sir.
Yeah, what happened, Paula?
I sent you an email po regarding po why I couldn't take the exam.
Yeah, did you answer the questions?
Yes po, answering po.
You forward already?
Yes po, sir.
Na-forward mo na sa akin or not yet?
Po, sa replies po.
Better forward it if you did the exam. Kailan mo pinorward, Pao?
Ngayon lang po, sir.
Send na.
Yes po, yes po.
How about Anbenis Biete? Dito ba si Ann? Biete. Wala. Anbenis not online. Okay. So again, as I have mentioned earlier, we will not go out of vectors, forces. We will not go out of this quantity. So please, those who insist of not following the instruction, okay, please read the module or the lesson that I forwarded. Do not insist of reading those previous solutions in previous years. They are not done correctly. I observed most solutions in the midterm, they did not copy the questions. They just go on solving and solving, writing and writing without following or answering what is being asked. And in solving the problems, they did refer to the module, to the lesson. Nandun lahat ang how to answer it. There is a procedure. For example, in the conditions of equilibrium, nakalagay naman doon, there are only two conditions. The first condition is the algebraic sum of forces is zero. Yung iba nilalagay doon yung second condition, torque. There is moment arm. That means those who answered that interchanging the first and second condition are not reading the module, are not listening during the lecture. That's the reason why I outlined the question so that it will be done in correct sequence. So if I check your papers, hindi nakalagay niya. Letter A, draw the force diagram or isolate the object of interest. E pag isolate lang, some don't know how to isolate. Bibilogan lang or enclose the object. Wala, basta solve ng solve. Okay. So that means maybe they are not listening during the lecture on the examples, lecture on the procedure. Okay? So, Pao, did you forward already? Pao de la Cruz.
Hi, sir. Yes po, sir.
Ba't wala pa sa email ko?
Baka po sa spam. I'll resend it na lang po, sir, right now.
We are supposed to go to the next lesson, but it seems some members of the class are not yet ready for the next lesson because dito pa lang sa vectors and the forces, medyo they don't know how to position like the normal force, the weight, okay, the friction. Hindi alam kung saan ilalagay, kung anong direksyon. So paano tayo move on to the other lesson? Okay. Let us go to saan ba yun? The examples. Okay, this example, it is in the handout on the module. First is, in the midterm, the first question there is isolate the objects of interest. Okay. Do you see this example in the screen, class?
Yes po, sir.
Okay. Pag-isolate lang, the reason why the objects must be isolated because we will be separating the objects from the system to construct the force diagram. Yun ang purpose. Okay. Now, how to, before isolating the object, you have to identify the object of interest. Class, the object of interest is very important here. Okay? Because we will be tracing the motion, the activity of the object of interest. That's why they should be isolated. Paano malalaman kung ito ay object of interest? So, makinig ulit. Okay? Malalaman na object of interest ito pag mayroong force acting on it. Pag may nakakabit na force. Ano ba yung force na yon? Either one of these. Capital F, the capital W, capital N, capital F, capital T. So, kung merong naka-attach na force on the object, that is called object of interest. O dito merong tension. Okay. So, this is object of interest. Also here, this one. So, you have to isolate. Paano mag-isolate ngayon? Okay. Kung ano binilugan mo or in-enclose mo, ayan. Okay. That is the purpose. Now, next is the force diagram. Ilipat mo ngayon ito doon sa ibang space. Kung ano na in-enclose mo roon, ilalagay mo rito. Yung iba ang ginawa, ito lang binilugan. Okay. Yung M lang, hindi kasama yung 30 degrees. So, kung anong binilugan dito, yun lang ilalagay mo na. Huwag mo isama yung sa labas. Ito, binilugan dito. Okay? I-copy paste mo, ilagay dito. Mayroong 30 degrees, mayroong small m. Meron yung sa string or rope. Ayun. Ganon. Nilagay din yung acceleration pataas. Nilagay din yung 8 newtons. Ayan. Okay. So, ito yung figure, enclosed figure ng small m. So, free body diagram or force diagram. Dito ngayon ilalagay yung mga applicable forces. Okay. So, eto ngayon, itong limang ito, masyadong malayo. Pwede mo ilagay rito. Kopyahin nyo ulit dito. Dito ka mamimili ngayon. Okay, meron bang F? Pag hindi mo maintindihan yung capital F na yan, pumunta ka sa definition nito, nandun sa module. It is a push or a pull acting on the body. Meron bang nagtulak? Meron bang humila? Dito merong humila, kailang this is a rope, so hindi pwedeng force. Tension siya. Okay. So, wala ito. Okay. Next, meron bang weight? Meron kasi given 8 newtons. Downward, vertical. Ayan. Nakikita nyo rito, pinasok yung tail dun sa object M para siguradong nakatat siya. Yung iba lang nakikita kong ginagawa ng ibang members, nilalagyan ng gap dito. Paano magiging weight yun kung malayo yun sa object? Natatakot ipasok yung tail ng vector doon sa object. So, pag dito mo nilagay, mali na kagad. Paano maging weight yun kung malayo yung weight dito sa object? Okay. Next, normal force. Meron bang normal force? There is, because normal force is the force perpendicular to the two surfaces pressing each other. Ayan. 90 degrees. Okay. O may nakita akong sagot doon. Ang normal force, pinarallel dyan sa weight. Paano maging perpendicular yon? Yung iba naman, ginawang parallel yung weight tsaka normal force. Hindi kasi tinitignan yung definition. Okay. Normal, perpendicular o 90 degrees. O, meron. Meron bang friction? Okay. Walang friction force because nakalagay dito frictionless. Pero doon sa natin, sa midterm, given ang coefficient of friction, kaya meron F. Hindi tinitingnan yung given data kasi hindi nilalagay yung mga given data. Okay? So, merong friction, tension. Meron kasi this is rope. So, before attaching this, titignan muna yung definition bago ilagay doon. Ngayon, ang nakita ko ng mali pinaggagawa ng ibang members, eto lang nakasulat dito kung ano-anong nilalagay dyan. W sin theta, W cosine theta. Wala naman dito eh. Eto kung anong sinulat dito, yun lang ilalagay muna doon sa force diagram. Mamaya na yung mga equation sin 30 degrees and so on. Para hindi kayo malito paggawa ng convenient access. Okay. So, pagdating naman sa convenient access, lagi kong sinasabi, ang motion or the acceleration will dictate the axis that you will use. Ayan. Yung acceleration niya, i-drawing muna acceleration doon. So, yan ang motion ng object. Doon, umaakyat siya along the 30-degree inclined plane. So, this established axis, okay, yun ang road or path of the object of interest. This is the object of interest. Saan siya dadaan? Anong direksyon niya? So, ito. This is the road or the path. This convenient x-axis. Ayan. Dito lang naglalaro yung object of interest. Pwede siyang pumunta roon, o pabalik dito, or what. So, this is the convenient x-axis. So, we have established already the road or the path of the object of interest. Nandito siya. Sinasabi ng direction of motion or acceleration, okay, pupunta ka doon, aakyat ka doon, pataas. So ano ngayon yung mga component, x-component or forces along this path or motion? Andun, tension. Okay. Ano ang component ng tension? T sub x. So, any other forces along the motion or along the path? Ito. There is a x component of the weight which is going down. There. Kasi pababa ang W sub x because the weight is going down, and if we get the components, it's the y component, that is the x component. So making a parallelogram or rectangle, kung WX yun, WX din dito. So this is WX. Papunta naman doon. So this is the convenient axis with the components. Okay. Now, since this object of interest is moving in that direction to the right, ayun no, yan ang direction ng acceleration. So this object of interest, for it to go to the right, okay, T sub x must be positive. Kasi yun ang tinuturo ng motion. Okay. And W sub x is negative. So positive x minus W sub x equals MAX. Yun ang equation natin ngayon because we will use this formula for the Newton's second law of motion. Susundin lang yung procedure. So this is the unbalanced force. This is the force that makes the object of interest move to the right along the inclined plane. This is the unbalanced force or net force. Ayan. So getting this, establishing the equation from this convenient axis diagram, we have to determine the equation for t sub x. Ano ba yung t sub x na ito? Ayan. T sub x and t are both on the x-axis, so they have the same or equal magnitude. So t sub x equals t. Ayan. Ano yung w sub x? It's the x component of the weight. And according to this triangle, w sub x is w sine 30 degrees. Ayan. So, we've already established the equation of the components. Iso-substitute lang doon. Iso-substitute din ito doon. Equals MA. Okay. Then you get the equation. Very simple. So, punta naman sa kabila. Same procedure. Isulat lahat dito to para malapit. Meron bang F, meron bang W, meron bang M, meron small f, tsaka T. Ayun. So this is the force diagram. Ang convenient axis, ayun, i-drawing mo na yung motion. Ito. So draw a parallel line. Ito yung path ng object of interest M, capital M. Nandito yung object. Dito lang siya dumadaan, no? Hindi siya pwedeng pumunta roon. Kasi itong pinili nating path niya. So, ilalagay nga yung mga components. Ano ang component ng T? T sub X. Ano ang component ng weight? W sub X. Okay. Now, go to the equation. This is the equation that we will use. So, for this object of interest capital M to go down or to the right, this must be positive. Yun ang negative. Mas mataas ito kaysa dyan. So, Wx minus T sub x equals MAX. There. Now, the problem now is, when I see the force diagram, okay, yung iba nga yung kokopyahin lang yung figure, hindi pa nakopyang mabuti. Okay. For example, ito yung M. Okay, small m. It must be tied with the string or rope. Eh hindi naka-attach dyan ang rope. Paano mahihila yung body? Okay. So sa video na lang, kokopyahin na lang, hindi pa naintindihan bakit putol dito. So pag bumaba yan at putol dyan, paano masasama ito? Okay. So here, okay, you must observe that you must be very careful in attaching the forces. Ito mo ito. Basahin mo na yung definition bago ilagay dito. Mahirap yung wala, yung weight tsaka normal force parallel. So, ibig sabihin, hinuhulaan na lang, hindi binabasa yung definition. In the normal force, the force diagram, pilit na nilalagay sa taas yung normal force. Okay. Bakit doon nilalagay yung normal force? Eh, wala naman dalawang surface dito. Okay, so that is example or the comment that I observed in the midterm. Any question, class? Uh, we will see who those members that are present today. Francis Author. Nandito pa si Francis Author. Absent? Nandito, okay. Gabriel Bautista. Anbiate. Aliana Kakbay.
Present po.
Gabriel Culiado.
Hello po. Mic test lang po. Present po.
Karoche Mikey. JP Del Moro. Pau de la Cruz.
Present po.
Para Estoconing.
Present po, sir.
Jubel Idolsa.
Present po.
John Magat. Prince Mapalo. Jemuel Miranda.
Present po.
Kelly Morales.
Present po.
Tricia Nerbesa.
Present po.
Cindy Nobora.
Present po.
Roy Oli.
Present po.
Ivan Pangantihon.
Present po.
Jan Prieto.
Present, sir.
Jocelyn Recto. Charles Ritt.
Present po.
Christine Sampilo.
Present po.
And Mark Villaseran.
Present po.
Hello po, sir.
Yes, Gabriel.
Chinat ko po si Biepe. Sabi niya po, yung midterm po niya nasa reply po nung midterm na email.
Pinasa niya yung midterm niya.
Yes po.
Where?
Sa may replies daw po.
The problem there, sinabi ko doon, do not put the, if you submit, forward your input, wag doon sa, mag-reply doon sa questionnaire. Okay. Click the mag-email button.
Yes po, sir. Nasabihan ko na po siya.
Because when I download, ayun na nga sinasabi ko eh, if I download the test papers, inaano ko na agad, dina-delete ko na agad because I downloaded already. That is the main problem kung hindi binabasa yung instruction. Ano bang mahirap doon yung choose the mag-email button? May problema pa roon. So that only your test paper will be attached there pag mag-email button ang option na kinuha mo. But if you reply on the email, lahat doon, using that, if they reply on my email, when I delete the that email after I download, napasama na sa na-delete. Okay? So, better resend the Nasaan ba si Ann Biete? Why she's not online?
Ang sabi niya po sa akin, nasa biyahe daw po. Di po siya makakonect.
That is the main problem. Pag hindi binabasa yung instruction at following the instruction, it's not my fault if I cannot be able to download that paper. Kasi hindi sumusunod sa instruction. Okay? In the other exam, number 2, that is statics, most answers there, okay, again, the problem or the question is not copied. Hindi nalagay mo na yung question. Okay. Kukopyan lang yung question tsaka yung figure. Hindi pa magawa. Okay. Because the figure must be drawn first kasi doon ibabasa yung force diagram. The force diagram must be drawn directly under the figure. Okay. Let us go to the example. Okay, this is the example. Okay. Nakikita niyo ba yung screen na Gabriel?
Yes po.
Okay. Ito yung example na binigay ko. Okay. O ito yung figure. Nakalagay, liwanag yung figure, hindi sinusunod yung sequence eh. This figure is very important, okay, because in making the force diagram, dito ibabase. Ngayon, I cannot see any reason. Hindi naman mahirap kopyahin yung figure. Okay? So I don't know why the figure is not copied. Kasi kung ito yung figure, mag-drop lang ng vertical lines. Ganon. Then, draw a solid line. That represents the uniform bar. The reason why it is drawn directly under the figure para siguradong pareho ang length or dimension. Then the points A dito, ang point dito, tsaka point B. So, if this is 1.5 meters, 1.5 din yan. 1 meter ito, 1 meter din to. 0.5 meter to, 0.5 meter. Ang ganda tignan. Okay. Yung iba, hindi midterm, hindi kinopya dito, kaya kung ano-ano na lang pinaglalagay dito. Okay? The first diagram. So that means this example is not being reviewed or seen by the others. Okay. Now, the next question in the midterm, nilagay doon, using the first condition, okay, establish the equation so that the beam will be in equilibrium. And what is the formula for the first condition? Algebraic of f equals 0. Yun ang first condition. Walang x components doon sa midterm. The question. Puro y component. Puro vertical. So, itong gagamitin. Algebraic of f sub y equals 0. Positive, pataas, negative, pataas. Simple lang. Yun lang ang susundin. Yun ang first condition. O anong pataas? Ito, positive. Minus, ito, tsaka ito, negative. Equals 0. That is the equation. Now, the problem there is, ito nga nilagay ang first condition, na formula, ang equation naman, torque. Ito ang nilagay doon, ang sagot. That's why I intentionally put letter A, first condition, letter B, second condition. And the others just answer, solve dito, hindi wala ng sequence. So kung sa first condition, itong equation nilagay mo doon, mali na. Wrong. Okay. I intentionally arrange the questions para doon ko maintindihan kung nakikinig kayo sa lecture or kung binabasa yung module. Wala. Kung anong solution ng kinopya. Procedure is very important, class. Okay? So, I would advise, again, some members of the class that do not follow the procedure, please read the lesson, read the example, ask if you did not understand the lesson. Ganun lang naman kasimple yun. Any question, class?
Sir, question po dun sa force and motion.
Yes, Tricia, ano mong question?
Kasi dun po sa example, yung inclined plane po is frictionless. What if kung present po ang friction? Ano po yung itsura po nun sa force diagram and convenient axis?
Sandali. Balik tayo doon sa... by the way, meron tayong second session. Alam niyo naman yung link. Pag mag-expire tong session na ito, we will meet on the second link. Second session, okay? Gabriel, did you hear me?
Yes po, sir.
Okay, nakikita mo ba itong screen na Tricia?
Yes po, sir.
Okay, please listen. The question of Tricia is very good. Okay, very good question. Ito, nilagay kasi dito frictionless kaya walang friction. Okay? Ang ibig sabihin nito, frictionless dito sa surface plane na ito, tsaka body, ganito rin dito, frictionless. Friction is zero. Ngayon, alisin natin yung frictionless na yan. So, ibig sabihin may friction given yung coefficient of friction. So, ibig sabihin nun, sigurado 100% there is friction force. So, ano mangyayari ngayon dito? So, here now, dati walang F is not applicable. Applicable na siya. So, yan ang motion, pataas, friction oppose the motion of the object. So, dito yung friction force. Pointing at the two surfaces pressing, interacting with each other. So, small f yan. Applicable siya. Ganon din dito. Ito ang motion, friction oppose the motion of the body, so pataas din siya dyan. Do you understand, Tricia?
Yes po, sir.
O, paano yung convenient access ngayon? Di lalagay lang yan. Okay. Ito, this is the object, opposing the motion, pupunta siya rito. F sub x for the friction. Kasi tinuturo niya doon pababa eh. So, pababa rin ito. Ano ngayon ang equation? Ito yung motion, so this is positive, yung dalawa negative. P sub x minus W sub x minus F sub x equals 0. Equals MAX. Yun ang equation. Okay. Do you have any question, Tricia?
Okay na po, sir. Thank you po.
Okay. So, is there any other question? Ganun kasi, magtanong kayo kung hindi naintindihan or hindi maliwanag. Okay. Please ask. Because I don't want you to guess what will be the equation that you will use. Okay. Oh, 8 minutes. Any other question? We have still 8 minutes. Doon naman sa statics, do you have any question there, Tricia?
Okay na po, sir. Understood so far na po.
I think dito sa mga example activity questions na dinidiscuss natin, it is done according to the procedure, nasa sequence yan. Okay. And again, I would like to advise the class also that do not forget the concept of object of interest. Pag sinabing object of interest, this is the object that we will trace or follow the activity. Okay? Dito tayo magbabase saan ba siya pupunta, sa anong dadaanan niya, anong force. na nakadikit dito sa object. That's why it's called object of interest. It's not only the force, the path, the motion. Because if you don't understand this object of interest or the activity of this object of interest, you will be lost. Initially, nasa inclined plane, 30 degrees inclined plane siya. Nakabitin siya sa rope, tension. Okay. Ang weight niya ganito, ganyan. Okay. These are the assumed direction. Bakit inassume natin ito? Kasi mas mabigat ito. So, the possibility now, it's possible this heavier mass go down. Susunod naman yon. Supposing we assume wrong direction, pababa ito, papunta roon. Okay. The effect here now, if we choose the wrong direction, magiging negative yung mga sagot natin. So, iko-correct lang yon. Dapat pababa ito, pataas naman yon. Ganun lang yon. We will arrive at the same magnitude, okay, but the sign is opposite. And always remember in Newton's second law of motion, okay, the direction is very powerful. Okay, the acceleration. So kung ano motion, the involved forces are positive. Halimbawa ito pababa, papunta roon. This will become positive kasi yun ang motion niya tinuturo the object of interest doon dapat pupunta. Okay? So, ito ngayon maging positive, yun ang negative. That's why I always am telling the direction or the acceleration dictates the axis that will use, dictates the path of the object of interest. And also dictates kung alin ang maging positive. Natural, positive to kasi ang direction papunta roon. And also, this must be greater than the other one. So, please bear in mind, the motion of the object of interest is very powerful. To get the axis, or to get the path, and to determine the sign of the vector. Dito nyo lang makikita, parang ang object ito pupunta roon, mas mataas dapat to kaysa dyan. Okay. For this object to go up, t sub x should be greater than w sub x. Ganun lang naman pag-analyze niyan. Okay, class, any question? Okay, in 3 minutes. Okay, we will meet at the second session at anong oras yun? 9 a.m. Thank you, class, for attending this first session. See you at 9 a.m. Thank you, class. Bye. Okay, class, we're back online. Okay. We will today we will start a new lesson. Okay. But before we start, do you have any question or problem in statics and force and motion? Those who are not have a concern on those lessons, please seek clarification or ask question. Because we will be using again those concept of force and motion and statics in the succeeding lessons. Kung hindi kayo magtanong, if you don't understand, lalo kayong mahihirapan sa next lessons. Any question? Ano bang tanong? Let us ask Ivan Pangantihon. May tanong ka ba, Ivan?
Wala naman po, sir.
Okay. Are you already, you understand already force and motion and statics, Ivan?
Yes po.
Okay. So about the other members of the class, Pao de la Cruz, do you have any question?
No po, sir.
Do you know to manage forces? Okay. Force is a vector quantity. It should be drawn correctly. And the forces involved, there are 5 forces. Okay. You should read the definition of these forces before you attach on the force diagram. Okay, let us start the new lesson. Okay, work, energy, and power. The first quantity that we need to understand is the term work. Okay, this term work is defined as the product of the displacement and the component of the force along the displacement. First, displacement is a vector quantity which gives the measurement, okay, and the direction of this measurement, that means distance, and the direction where the object is going. That is the displacement. We have already defined this and covered this already in velocity and acceleration lesson. Component. So again, the term component refers to the X and the Y forces. X component means the X component of a force that lies along the x-axis, and Y component of the force is that force should lie on the y-axis or vertical. Okay. Now, according to the definition of work, the displacement and the force along the displacement, or they must be parallel to each other along the displacement. So if you have this body where a force, unbalanced force is applied, if you see a vector quantity force, there is bar or direction on top, that means this is the unbalanced force. This is the force that cannot be balanced. So it's this force that actually moves the object. To that, this body or this object will change its position. There is motion. Now, what is the work done on this body? It is the product of the displacement S and the force along this displacement. Okay? They have the same direction. So the general formula for work is F times S, which is W equals F. This must be multiplied. Okay, X equals Fs. Now, supposing the applied force is not parallel to the displacement, it is at a certain angle with respect to the horizontal or with respect to the displacement. So what will be the equation of the force? Since the definition of force is, of work is displacement multiplied by the force along the displacement, so if this is the displacement S, the force along this displacement is the X component of this force, so F sub X. So the work done on this body is W sub X multiplied by the displacement S. And what is W sub X? Is F cosine theta. Therefore, the work is S multiplied by F cosine theta, or W equals F times S. This is the general formula for the work, W. Okay? Where theta is the angle between the two vectors, F and S. Now, the angle theta, that is between this displacement and the force, If the angle theta is 0, that is horizontal, the work is F times S because cosine 0 is 1. But if the angle is, for example, 30 degrees, okay, the work done, W is equal to S multiplied by F cosine 30 degrees, which is 0.866. The work is equal to 0.866 F times S. But if the angle between the displacement and the force is 90 degrees, or if they are perpendicular to each other, what will be the work? Cosine 90 degrees is 0, so there will be no work done on this body if the angle is 90 degrees or if the two vectors are perpendicular to each other. So in here, we cannot measure a displacement because the applied force is vertical. So there is no work done. There will be no work done if the displacement S and the applied force are at right angles with each other. Cosine 90 degrees equals 0. Okay. So that is good regarding work is concerned. This will be our general equation. F sub S cosine theta. Of course, if the angle 0, it is W times S. But since force is applied at an angle more than 0, this will be the formula. Okay. Now we have okay, there are example problems on work. Okay. So I would suggest follow the procedure, write what is given, required, and the figure. Since there's a force applied, the force must act on the object. Laging ang force nakadikit sa object. Okay. So if you draw the, if you write the known and unknown data, then the figure, the general equation, the general formula is W equals F times S, or W equals F S cosine theta. There. Next term that we need to understand is energy. Okay. Energy is defined as the ability or capacity to do work. The property of a body or system of bodies by virtue of which work can be performed is called energy. So it is the ability or the capacity to do work. Here we will be dealing with two forms of energy, that is mechanical energy, which are the kinetic energy and potential energy. Kinetic energy is energy in motion, okay, and potential energy is energy of position or configuration. Now, first, what is potential energy? Since energy is the ability to do work, and work is the amount of activity to be performed. There. So the units of energy and work are the same. Work is the amount, and energy is the ability to perform that amount of work. Okay? So potential energy, an object may store energy because of its position. So this term, position or configuration, refers to the elevation or height, that is position. The energy that is stored is called potential energy because in the stored state, it has the potential to do work. So in this figure, if this body or this object is at the lowest position, or say in the ground, and if this body is elevated or raised at a certain height or distance from the ground, that is at point 2, okay. So this body now is at the atmosphere or the air, and the force diagram of this body is only the weight is applicable, and weight is mass multiplied by acceleration of gravity. So speaking of force diagram, to understand what is the force applicable, isulat lagi yung limang force. Capital F, W, and small f, and T. So in these 5 forces, only W is applicable here. Okay. Yeah. So since the weight is a force, okay, and because of this weight, okay, the earth, if earth is here, the earth attracts this body, and the force of attraction is of the earth on that body is equal to the weight of the body, mg. So again, because of this weight, this body will be moving vertically downward towards the earth, and its acceleration is equal to acceleration due to gravity g. Okay. So from the formula of Newton's second law of motion, since this is moving downward, it's free fall, okay, the force or the work is equal to the force multiplied by the displacement, and that force is parallel to the displacement h. Yeah. Therefore, the work done on this body is equal to the weight multiplied by the displacement, W times h, where W equals mg. So the work done on this body is mg times h. That is the amount of activity to be done on this body. And the ability to do this amount of work is the potential energy, which is P times P equals W times H. Okay, that is as far as potential energy is concerned. Okay. This is the amount of work MGH, and the ability to perform the work is potential energy equals MGH. So this will be our general formula for potential energy. Okay. Where W equals this is the weight equals mass times acceleration due to gravity, and potential energy is mg multiplied by h. Now, please note the value of g, acceleration of due to gravity, is depends on the system of units used. Okay. If the mass is given in kilograms and height in meters, G will be 9.8 meters per second squared. Okay. If the mass is given in grams and height is in centimeters, G will be 980 centimeters per second squared. This is the value of acceleration due to gravity. Okay. Kinetic energy. Kinetic energy is the ability or capacity to do work by virtue of motion. Yeah. And it's denoted by capital KE, that's kinetic energy. And the formula for kinetic energy is derived from Newton's second law of motion and uniformly accelerated motion. There. So this formula, this is the second formula of uniformly accelerated motion. Okay. And F equals ma is the formula of Newton's second law of motion. So combining these two formulas, okay, the formula for kinetic energy is derived as K equals 1/2 mv squared. So take note of the derivation, where kinetic energy is Ke, m is mass, and v is the velocity. Okay. So we have three formulas already. The formula for work equals F times S cosine theta. Formula for potential energy equals mgh. And formula of kinetic energy is 1/2 mv squared. Transformation and conservation of energy. So energy is given to a body or system of bodies when work is done upon it. Okay. So the ability. In this process, there is merely transfer of energy from one body to another. So this is the transformation of energy. In such transfer, no energy is created nor destroyed. It merely changes from one form to another. This statement is known as the law of conservation of energy. So conservation, pag sinabing conservation, no energy is destroyed or created. It is conserved. It is transferred or transformed to other form. Now, so since you are dealing with mechanical energy that is in the form of kinetic energy and potential energy, there will be this two energy will follow the law of conservation and transformation of energy. That means kinetic energy is transformed or changes to potential energy, and potential energy is transformed to kinetic energy, that is conservation. A typical example of conservation of energy is the simple pendulum. Do you see the figure, class? Gabriel, do you see the figure?
Kita po, sir.
Okay. Now, this is a simple pendulum. You can see simple pendulum attached to a wall clock. Okay. The simple pendulum attached on old wall clocks. So if the pendulum is raised to a certain height here, this is the pendulum, it is raised to a certain height. Now this pendulum is constructed, this is a ball, okay, and tied or suspended by means of a string or rod, so that this length is the radius of the pendulum. This is a fixed radius. So, if this pendulum is raised to a certain height, it oscillates until here. Therefore, this pendulum, the path of this pendulum is a perfect arc of a circle. Kasi radius yan. So, it will follow a curved path. Anong pang curved path na ito? It is a curve of a circle. Okay? An arc of a circle there. So, making this as the lowest elevation or elevation 0, this will be our reference elevation. So, elevation 0, and when it is raised at a certain distance h, this pendulum will reach the maximum height. Hanggang dito, maximum height. So, when this pendulum reaches the maximum height, it will momentarily stop. Titigil siya rito. So, at maximum height, the velocity is 0. Now, because of the weight of this pendulum, this will be forced to go down. Babalik siya. So, from velocity 0, will go down, the velocity will increase until it reaches the lowest point where the maximum velocity exists. Dito ang pinakamabilis. From zero velocity will increase until it reaches the elevation 0 at lowest point. Maximum velocity rito. Okay. Because at it passes the lowest point, magdi-decrease na ngayon ang velocity rito. Pakyat. Until it reaches the maximum height, the velocity is again zero here. So we have identified the maximum points. Here is the maximum height. Also on the other side, this is maximum height. At maximum height, the velocity equals zero. So it will go down. Velocity increases until it reaches the lowest point, elevation zero. So at elevation zero, h equals zero, the velocity is maximum. Then it will go up, decreasing velocity until velocity zero at maximum height. So we will now identify the energies. At the highest point, or maximum height, what are the energies here? The potential energy is maximum, is equal to mg times h maximum. The kinetic energy is zero because kinetic energy is 1/2 mv squared. So if the velocity is zero, kinetic energy is zero. Therefore, at this point, maximum potential energy, kinetic energy is zero. At the lowest point, where the elevation or height is zero, okay, there is no potential energy here because potential energy P equals mgh. If h equals zero, potential energy is zero. Now, kinetic energy is maximum because the velocity is maximum. So K is equal to 1/2 mv maximum squared. Then at the other side, potential energy maximum, kinetic energy zero. So since there is transformation and conservation of energy, what is being transformed now? From maximum potential energy, it is transformed to maximum kinetic energy, then transformed to maximum potential energy. So the energy will, since the pendulum is oscillating, the transformation is from maximum potential energy to maximum kinetic, maximum potential, maximum kinetic, maximum potential. But it is continuous. Okay. So the equations here are maximum values. P maximum equals 1/2. P maximum is equal to mgh maximum. Okay. K maximum is equal to 1/2 mv maximum squared. This is as far as these points are concerned. Okay. Any question, class? May tanong ba kayo? So the equations, okay, on these 3 points, actually this point and this point are the same. Both maximum potential energy, while here at the lowest position is maximum kinetic energy. Now, the path, okay, the pendulum is our object of interest now. Okay. Why object of interest? Because if this is a string, okay, or rope or rod, there is tension. There is also weight, W. So object of interest. So we will be tracing the motion of the object of interest. And what is the path? Saan ang path ng object of interest ngayon? It follow a curved path. And that curved path is a perfect arc of a circle. Ayan. So since this pendulum is oscillating, pabalik-balik yan, nag-oscillate siya, along this curved path, okay, the energy is conserved. There is no energy lost or destroyed or created. They're conserved. So the energy here is equal to the energy at this lowest point, also equal to the energy here. That means the sum of the energy here at the highest point, that is potential energy plus kinetic energy, is equal to the potential energy plus kinetic energy here, also equal to the potential energy plus the kinetic energy at this point. It so happens that the potential energy here is maximum, kinetic energy 0. So maximum potential energy is equal to maximum kinetic energy is equal to maximum potential energy. Now, along this curved path, since there is conservation, if we have a point in between here now, say point 1, what will be the equation for the energy here? What will be the energy equation here along this curve? Any answer from the class? Anong magiging equation natin in between? Say point 1. Let us ask Farah Estokoning. If you have the idea, Farah, what will be the equation on the curve path between these 2 points? Say here at point 1. Are you listening, Farah? Nandiyan ba si Farah? Farah Estokoning, do you hear me? I think Farah is not listening. Okay. Gabriel, do you have idea what will be the equation here in between?
Hindi ko po sure. Hindi ko po alam.
Okay, as I have said, the energy equation here is maximum potential energy plus kinetic energy. Okay. It is equal to maximum kinetic energy plus potential energy here, also equal to maximum potential energy plus kinetic energy. Therefore, if the pendulum is at this point 1 in between these 2 points, the equation is still potential energy plus kinetic energy. But in this position, okay, there is height, there is also velocity, so both exist. So ang equation dito is potential energy at point 1 plus kinetic energy at point 1 equals any of this energy here, because energy is conserved. Walang na-create or destroyed. So if potential energy plus kinetic energy here equals potential energy plus kinetic energy dito, ganoon din dito. Potential energy at point 1 plus kinetic energy at point 1. Equal dyan or equal dito or equal dyan. Energy is conserved. If there is another point here, point 2, ganoon din. Kinetic energy at point 2 plus potential energy at point 2 equals the energy here or equal to the energy here. That is how to interpret this conservation and transformation of energy. Do you understand that, Gabriel?
Okay po, sir.
How about the other members of the class? Okay. Okay, the session will expire in 10 minutes. So, do you have any question?
Sir, nasanda po ba yan sa email or hindi po? Nahanap ko po.
Yung,
Yung ano po, yung pages po.
this, nakikita nyo ba itong screen on transformation and conservation of energy?
Kita naman po, sir. Pero yung copies po.
Ipa-forward ko sa inyo. Okay.
Sige po.
The reason why I did not forward yet, kasi gusto kong maintindihan nyo ng concept. Para pag basahin nyo na yung lesson, ito pala, ganito pala yon. Okay. I will forward the copy of this after this class. Okay. So, may tanong ba kayo tungkol dito sa conservation?
Sir?
Yes.
So, bale po, energy is conserved lang po if and only if wala pong force na, na may introduce na bago. Like, lagi po siya makakonserve.
Yun laging may force. Force is involved here. Bakit involved ang force? Kasi ang work is force times displacement. So, kagaya sinabi ko sa inyo kanina, this pendulum, this body, it is the object of interest. Merong force involved. Bakit involved ang force? Kasi there is a work done. And the formula for work is force times displacement. Hindi mawawala ang force. So, if you compute for the work, for the energy, you use the formula F times S. Ang sinasabi ko rito is, do not disregard the object of interest. It is very important. Kasi ito yung kagaya sa force and motion and statics, Yan ang sinusundan natin object of interest. Laging may force. Laging may direction. Ano yung direction niya? Path. Yun din ang parang convenient access doon sa force and motion. It is a curved path. That's why, sinasabi ko sa inyo, yung concept doon sa pinag-aralan nating force and motion, nandun pa rin. May force diagram, mayroong force, mayroong convenient access, mayroong path. Again, that convenient access that we are referring is the path. Yung road where the object of interest is following. Ayun. So, do not just say, nasa conservation of energy tayo, wala nang force involved. Meron. Kasi may work. And work is F times F. Okay. Hindi na kailangan ng force diagram. Meron. Ang force diagram nito is W, pababa. Okay. Tension, papunta roon. Okay. Yun lang, tension and weight. Walang normal force kasi wala namang ibang surfaces. Walang friction because only one surface. May tension tsaka may weight.
Saan po ulit papunta yung direction ng tension? Saan po ulit papunta yung tension?
In this point, ang tension there, it is a pull in the direction of the rope.
Okay po. Thank you po.
Definition yon. Kung maglagay ka ng tension dito, pupunta ka sa definition. It is a force that pull directed towards the direction of the rope. It is a pull. Yung iba kasi hindi pwedeng push. Okay? Kung rope ito, hindi pwedeng push dahil mayuyupi lang yung rope. Pag tinulak mo yung rope. Because this is string or rope. Okay? It is a pull. Ang weight naman, pababa. Laging pababa ang weight. Okay? So I hope you read, I will forward the lesson, basahin lang yung concept. So that next meeting, if you have any question with regards to the lesson, magtanong kayo for clarification. Okay. So that is, we have already discussed work and energy. Next meeting, we will discuss power. Do you have any question, Para?
Wala po, sir. Sorry po kanina, sir.
Okay. So, again, please read the lesson. Huwag niyong kakalimutan yung force and motion lesson. Laging kasama sa from the start up to the end of our course. Okay. Okay, I think that our session is expiring. Thank you, class, for attending this second session. See you next meeting. Stay safe and have a good day. Thank you, class. Bye.